All right, here we go. Section 2.4. We're going to talk about average velocity, instantaneous velocity, and tangent lines to a curve. So up until now, we've already talked about average velocity and instantaneous velocity. But let's talk about, if we're not talking about a position curve, we're just talking about a regular function, x cubed minus x. If I asked you to find the average rate of change over the interval from 1 to 3, hopefully the words rate of change jump out at you as slope, and the word average means the slope of the secant. So the first thing I'm going to do, I'll do it over here, is I'm going to find f of 3, and then I'm going to subtract f of 1 and divide by 2, which is 3 minus 1. So f of 3, plug it into your function, 27 minus 3 is 24, minus f of 1 is 0, all divided by 2, it's 12, and we don't have a unit on this because we're just talking about a random function. So the average rate of change between 1 and 3 is 12. That's the slope of the secant. The slope between here and here, if we were to connect the dots and draw a line, the slope would be 12. So now we don't want to talk about average rate of change. We want to talk about instantaneous rate of change. And in order to do that, let's see if I can make this stop focusing. 1 second. Oh, I know, there's a button. I got you. There we go. Instantaneous rate of change is the slope at a point on this graph, just at one single point, or the slope of a tangent line. Well, the first thing you have to know is what a tangent line looks like. A tangent to the curve is a line that touches the curve at exactly one point. We've been talking up until now about secants. If you connect this dot and draw a line, you would have a secant line. But if we're talking about right at this exact point, what is the slope of the tangent line? So the slope of the secant goes along with average rate of change. The slope of the tangent has to do with instantaneous rate of change. And for that we were using this formula, which I don't know if it was called the difference quotient at that point, but that's what it is. This is the difference quotient. Remember, we've talked about how h is really small. So you're basically finding the limit as this gets really small of the slope between x plus a really small number and f of x. Okay, so let's use this curve and let's find the instantaneous rate of change at x equals 1. So we're going to use the difference quotient. We're going to find, remember, instantaneous rate of change is the slope of the tangent. So I want to find the equation of the tangent to this curve at x equals 1. So I'm going to say the limit as h approaches 0 of f of, I'm going to use 1 for x, minus f of 1 all over h. So the limit as h approaches 0, I'm going to plug in 1 plus h for x. And we already found out that f of 1 was 0 from our original problem. So I'm going to plug in 0 for f of 1 all over h. Now we have to do a little algebra. Let's go over here and do 1 plus h cubed. 1 plus h times 1 plus h times 1 plus h. So I'm going to FOIL these first two, and I get 1 plus 2h plus h squared. I'm going to multiply that by 1 plus h. And then I get 1 plus h plus 2h plus 2h squared plus h squared plus h cubed. Combine my like terms, and I get h cubed plus 3h squared plus 3h plus 1. So that's this. So now I have the limit as h approaches 0 of h cubed plus 3h squared plus 3h plus 1 minus, don't forget to distribute the negative here, minus 1 minus h. I'm not going to write minus 0 because that's just silly. And now simplify. Combine like terms. I have h cubed plus 3h squared. 3h minus h is plus 2h, and 1 minus 1 is 0, all over h. Factor out an h. And plug in 0 for h because we're talking about as we approach 0. And you will find that the slope of the tangent line is 2 at x equals 1. What is she talking about? Well, you can see if you look at this curve that the slope here would be positive, really big number. Slope here would be positive but still a little bit smaller. It depends on the point on the curve in which we're talking. Well, I'm talking about this point right here. And I'm saying the slope at this point is positive 2. Let's look at it on the calculator. The slope at x equals 1 is positive 2. That's all well and good, but the question asked for the equation of the tangent line, not just the slope, the equation. So let's think about what we need to write the equation of a line. We need a point and a slope. And all I know is that x equals 1 and the slope is 2. Do I know the y value? Well, hopefully you recognize that this is a function, and when you plug in 1 for x, you get a y value. So this point on the curve, which is very poorly drawn now that I look at it, is 1, 0. Let's look back at the calculator. You can see that the point at 1 is 0. So the x value is 1, the y value is 0. I got the y value by plugging the x value into the function. And now I can write my equation of a line using the point slope form. I'm going to plug in 0 for y1, so I just have y. I'm going to plug in 2 for x. I'm going to plug in x minus 1. That's the equation of the line. Now if you would prefer it to be in slope-intercept, just distribute your 2, and that's what you have. Now let's look at how awesome this is. I'm going to go to the calculator, and I'm going to draw the line 2x minus 2. And you're going to see that it is exactly tangent to this curve at x equals 1. Shazam! So awesome. So I could have done this for x equals -1. I could have done it for x equals 5. The slope would have changed, which is weird because your whole life you've always heard slope is constant, because you've always been talking about a line. The slope of this red line is constant. It's 2. No matter which 2 points you pick, the slope is 2. But when we're talking about a polynomial function or a rational function or an exponential function, the slope at a given point along the function is different. So to find the slope at a point, we have to use the difference quotient, which we just did, which we're going to do again right now. Let's do x squared at the point x equals 2. Write the equation of the tangent line to x squared at the point x equals 2. So f of x equals x squared. We want the equation of the tangent at x equals 2. The first thing you have to do is find out the y value. When x is 2, what's y? 4. So now I have my x and my y. All I need is my slope. Slope of the tangent is the difference quotient. Limit as h approaches 0 of f of x plus h minus f of x all over h. So the limit as h approaches 0. X in this case is 2. So I'm going to do 2 plus h squared minus f of x, which is 4. Right? When I plug in 2 to the function, I get 4 all over h. Foil this out. Simplify. The 4's cancel out. You just have h times h plus 4 all over h. The h's cross out. Plug in 0 for h. And the slope at this point is 4. So the equation of the tangent line is y minus 4 equals 4 times x minus 2. Let's just solve for the fun of it. You do not have to. Distribute, I get 4x minus 8. When I add 4, I get 4x minus 4. So let's look at the calculator. We all know what x squared looks like, hopefully. It's just a parabola. And the line, 4x minus 4, looks like this. It should be tangent to the parabola at x equals 2. If we did it correctly. And there you go. Right at the point x equals 2, it's tangent. Now it looks like it's tangent all along here. That's just because the calculator is, we can zoom in a little bit. Let's go from x from 0 to 3. And y from 1 to 5. So there's the parabola. And there's the line that's tangent right at that point. It still looks like it's going along, but you get the idea. Right at x equals 2, the slope of this line is 4, the equation is y equals 4x minus 4. So that's the general idea on how you get the slope of a tangent to a curve. You have to use the difference quotient. Now there's one other thing you have to be able to do in this section. That's write the equation of the normal to the curve. Again, we're still talking about at the same point, but you have to know that the word normal means perpendicular, and perpendicular lines have opposite reciprocal slopes. So the tangent to the curve has a slope of 4. The normal, or the perpendicular, is going to have a slope of negative 1/4. That's the only thing you have to do. It's still the same point, so you still do y minus 4. This time your m changes, and you still do x minus 2. And then when we solve, we have negative 1/4 x. This is a half plus 4 is plus 4.5. It's better to write 9/2, but let's take a look at that line. It's going to be a new line perpendicular to the red line, which is the tangent, at the point x equals 2, y equals 4. Negative 1/4 x plus, I'm going to go 9/2 just because I don't, actually I'll show you how to do a mixed number. Choice 2 on alpha y equals is a mixed number. So you can do 4 and then 1/2. Now the graph, the calculator's a little bit skewed, so they don't look perpendicular, but I promise you, they are perpendicular. The slope of the red line is 4, the slope of the black line is negative 1/4, therefore they are perpendicular. So the equation of the normal, all you do is take the slope of the tangent, make the opposite reciprocal, use the same point, because you still want to be normal to the curve at the point 2, 4. So you still have the same point. Alrighty, shall we try one more for the fun of it? I think we shall. Find the equation of the tangent to the curve 4 minus x squared at the point 1, 3. Now, this is where my students freak out. I don't know what to do when they give me a y value. I could have said at the point x equals 1, and you would have plugged in 1 and gotten 3. Sometimes they give you the y value, sometimes you have to find it. Either way, that's where these numbers are coming from. Let's find the equation of the tangent and the equation of the normal to the curve. Well, the first thing I might want to do is start off by showing what I know. I almost have the whole equation. I just need the m. So in order to get that, we're going to use the difference quotient. Limit as h approaches 0. X equals 1. So f of 1 plus h minus f of 1 all over h. Limit as h approaches 0. Plug in 1 plus h, I get 4 minus 1 plus h squared. Minus f of 1 is 3 all over h. So now I'm going to FOIL this guy, get 1 plus 2h plus h squared, and distribute the negative. So now I have the limit as h approaches 0 of 4 minus 1 minus 2h minus h squared minus 3 all over h. Combine like terms. 4 minus 1 is 3, minus 3 is 0. So now I just have negative 2h minus h squared all over h. Well, what do you want to factor out? An h. So I have negative 2 minus h all over h. Plug in 0 for h, and the slope is negative 2. So if you put this on your calculator in y1, and then you solve this for y, so negative 2x plus 2, and then add 3, y equals negative 2x plus 5. Type that line into y2. This line should be tangent to this curve at x equals 1. And that, my friends, is how you write the equation of the line. If I were to do the normal, I would have this exact same formula, but instead of -2, I would use positive 1/2. Alrighty, happy studying. Now,